All right, good afternoon, good evening, or good morning if you're virtual. So welcome here to today's talk. We're going to be talking a little bit securing your resources with short-lived certificates. So here it's mid-afternoon after lunch, so hopefully I won't put you to sleep too bad. But anyways, a little bit about me. My name's Vailliencourt. I'm a sales engineer with Teleport. We're one of the sponsors here, and we have a booth downstairs. And I've been in the sales engineering world for a number of years now, but joined Teleport earlier this year. But I always like to start off, say, hey, I do have a life outside of being a geek. I got my wife, my two kids, which have made me pick up a lot of swag this week, so let them fight it over. When I'm not doing technical stuff, I like to, my fidget spinner of choice is our Rubik's Cubes. So I like to, showcase that a little bit. It's a fun little, when you're on a boring call, especially if you're working remotely, solve a cube or something. And then our newest addition to our family is a schnoodle. So this is back in May when we got her. She's a little bit bigger than that now, but it's like having, if you haven't had a pet in a while, it's like having kids all over, the late nights and dog whining. But anyways, you can find a little bit more about me, what I do, and my link there and here on the slides. But anyways, let's jump into it of today's conversation about why short-lived certificates, and what is that? How is that relevant? Why is that important? So most people that I talk to, a lot of companies, a lot of folks, I ask, how are you accessing resources today? Whether it's SSH servers or Kubernetes or databases. We're familiar probably with this picture here, right? We generate a public-private key, we SSH in using that key file, and then we've gained access to our resource. For those of you that are on the sysadmin side or Linux administrators, you're probably used to seeing this from a server side, right? If you cat your authorized keys list, this entry for demo only has one, but you probably look at one of your servers, it probably has a couple extra entries, probably a couple dozen, if not a few hundred. So the question is that I like to ask is, do you know of all these keys that you have put out in your environment, do you know which ones are valid? Which ones are not? Is that user still there? Are they gone? And so a lot of times, people might I have no idea. We just threw the key up there and life goes on. So I kind of look at the PKA public key authentication as a few pros. We all use it, been using it for a while. It's not going anywhere anytime soon and along that line. The idea behind PKA is really better security, right? So when you have a good PKA system in place, users don't have to remember complicated passwords for each and every system. Whereas, just 10 years ago, you're probably logging in your systems with a unique password, or maybe not. Actually did talk to somebody yesterday, they're still using passwords to access their systems, so they still haven't even gone to public keys yet, or private keys. So, and with a PKA system, right, you can automate processes. If you're doing a git push, right, to your repository, you're probably using a key that you have uploaded to GitHub or GitLab or Bitbucket in order to kind of automate some of that process along the line. So we touch PKA all the time. And it's easy to create and deploy new keys. Literally that command, right? SSH keygen, and then what type? ED25519, RSA, whatever you want to do is, myriad of options out there. That's a whole nother topic of discussion as far as which one's better. So, summary there, it's hard to find systems that do not support PKA, because pretty much everything out there does. So, I have this here. It's like, why change from using keys that you're using today to certificates if they have all these wonderful pros on it? So why should you change? Change my mind there. Well, let's look at a few, I don't say cons, but some things, considerations that you can look at. So what happens when your user moves to a new role? They leave the job, they leave that role, they go to a different department. Maybe they've been promoted, so they're no longer an admin or something along that line. What if their device, their laptop, server, or something gets compromised, gets stolen, and they had all their private keys on that laptop? So this article here from SSH.com talks about keys in circulation today. So you just look at it there, right, where in their article, in their survey talking, one financial sector customer, 3 million keys, 750,000 distinct key pairs from 15,000 servers. Another case, 4.5 million authorized keys from 100,000 servers. So in your own mind, just calculate out. Maybe you're like, well, we're not in the tens of thousands, but maybe you have 30 developers and you have 15 servers. You know, you do the math, if there's a key on every one of that, and next thing you know, you've got hundreds, if not thousands of keys that you're trying to manage and figure that out. So what about when someone accidentally commits their private key to their public repository? I'm sure that's never happened with anyone here, hopefully not, but it has. You know, within minutes, that key can be utilized to log into a service and cause chaos. This happened a number of years ago, a place I was at, where we had a new DevOps engineer who was relatively new to GitHub and, you know, keys, and he had his AWS PEM file. You guys can probably see where this is going. And he had it in his repository, did not have a git ignore, and he pushed it out. Well, the repository was a public repository. Within literally minutes, that key was scanned and compromised. And then within hours, we had 200 servers spun up in every AWS region around the world because his key was compromised. So all of us, all hands on deck, right? Forget everything. We're logging in, revoke the key, manually deleting servers, and you know, and working with AWS billing to say, hey, can we not get charged a couple $1,000s for that? So, you know, scaling out deployments with keys can become challenging. As I mentioned earlier, you know, businesses are using homegrown methods. I used to use Ansible playbooks, right? Hey, new dev on board, send me your public key. I'll run the playbook, and we'll upload it to every host. Oh, a new user left. I did not know that. What was their key? Maybe I'll delete it if I remember. So, and there's also some commercial and open source vaults, and you know, like HashiCorp Vault and Keyless and others that you know kind of manage that. But right, you know, keys, and the other, you know, consideration to think about, or the con, is that keys don't expire. I had somebody come by our booth yesterday, and he's like, oh yeah, I'm using the same key from 2017. So, right, so he's like, okay, it's great. It's like, you know, they don't expire, so it's convenient and it's easy to do. So here's the thing, segueing that into SSH certificates. Did you know that OpenSSH started supporting certificates back in 5.4? So how long ago was that? March of 2010. So you have had access to leverage SSH certificates since 2010. And you're like, some of you are probably thinking, whoa, what? You know, mind blown. It's available, but why have I never utilized it or touched it? So the next part of this, we're going to talk a little bit about that, and then I'm going to show you how you can even just get started using SSH certificates even today. So what is an SSH certificate? In essence, it's like any other kind of certificate out there. There are certain properties and tags on that certificate that you need to be aware of. Here, this image here, and it's off we have a blog article that gives way more in detail of what it is, but you know, a couple of things there is, you know, what kind of certificate is it? Is it a host certificate? Is it a user certificate? So like all of you accessing a resource would be a user certificate, and your host to another host potentially would be a host certificate. Your signature key, the valid principles of, you know, some comma-separated line of who are the principals of that certificate, what users. A key thing here, which is what makes, I think, certificates really shine, is a valid after and before date, setting a time to live on a certificate. So that way there's a limitation, so we don't have somebody running the same thing for 5 years. You actually have an expiration date on it. And then some extensions, and then you have your signature of that certificate that's been validated and signed by a CA. So it says, hey, if this gets tampered with, it invalidates that certificate. So segmenting that, what does that have to do with Teleport? Well, Teleport is an open source project that's been around since about 2015 and founded by a couple engineers that had another startup, they sold it, and they realized they needed an easier way to access resources besides passwords and vaults and things like that. So we call it an access plane, where you can access servers, Kubernetes access, application access, and even database access. And they decided to make it open source because that was in their DNA. It's in our DNA as a company. And going out there where you can get started and get it running immediately. So that kind of balances out in today's security world, that security versus agility piece of the puzzle. As developers or DevOps, you have this big principle, the whole mantra of DevOps besides the culture is being agile, being able to react, being able to deploy something quickly or rapidly and getting something out there. But then you have on the other side of the fence your security team, right? Any security people in here? All right, we won't cut you down. But they're a critical piece, but yet we all know security, their job is to prevent things from happening. And so that becomes many times a barrier of accessing resources because everything is locked down. And so it's this scale, this balance that you got to manifest itself from security and being agile. If you have too much security, you're not agile, right? But if you're too agile, there's probably not a whole lot of security within that environment. And so striking that balance and having the right pieces of the puzzle in place. And that tension manifests itself in areas like access workflows. How can I gain access to what I need? Credential management, right? Nightmare. All right, you're on access. Now, how to get to this server? How do I get to this Kubernetes cluster? How do I get to this database? And then, of course, what security and the auditors love is compliance and auditing. Being able to know who was on what system, who was doing what was happening within that system, and managing that. So we're going to dive here in a little bit into some of the pieces of Teleport and the aspect of that kind of strikes that balance between this. So we're using identity certificates, as I mentioned and kind of talked about a few minutes ago, about users using their credentials, signing to an SSO provider, and then that provider being your source of truth saying, hey, Jane Doe, you have admin rights, you have rights to this server, this cluster, et cetera. And then coming across on Teleport saying, all right, that source of truth says I should have this, so let's grant you those roles so that you can have access to those systems. And and like I mentioned, it's probably in the wrong order here, but being an open source product is foundational because what we build and what we put out for our customers, they want to know what's happening within that product. So we're on GitHub as of actually this week or last week, we're at 10,200 stars. So it's a very active project and where you can actually go out there and see pull requests from developers and feature requests from people accessing things or having issues. And it's kind of part of our leadership core and our developers about being transparent as far as a roadmap aspect for companies to run things. And we've got customers running production instances of Teleport within, using the open source and not having any issues at all. And a little bit of who uses it besides, open source users. There is an enterprise piece of the puzzle, but just highlight that quickly. But I'm not going to talk about that detail. You can always come by our booth to find a little bit more. But we do have an enterprise offering which provides that value of open source, but having an enterprise option where sometimes you just need support along that line. So a couple features within the open source that you can actually pull down today, get started, and we'll show that here in a quick demo, is a unified role-based access control as one piece of it. So you're synchronizing your role-based access across your clusters, SSH nodes, databases, and applications. So with open source, you can tie into a GitHub as your OIDC platform. So if you've got users and teams and groups within GitHub, that can be your OIDC and parse it and kind of leverage it along that line. Then you have this audit log as well that restricts that you can kind of see what's happening. So when a user logs in, when a user attempts to log in with an expired certificate, or if they run a Kubernetes command or a database command, that our audit log is going to show what is happening within that environment. So from a compliance aspect of it, being able to see and insight into that. And of course, you can actually push this information out to your own SIEM. So people that use Splunk, Elastic, Datadog, and Logarithm, Devo, others, there's an opportunity you can push those recordings, those audit logs out there. And this is a really small little animated GIF here about, we do SSH and kube control session recording. So when someone's actually on a server, that you can actually, you're actually going to get a session recording of it. So if someone's like, hey, coming on a Monday, someone on the weekend was on a production server, you can see, session recordings of what happened within your environment and actually play that back from the web or from your desktop CLI and kind of know what is happening within your environments. And of course, we also have real-time, user on-off boarding. So as permissions change, or you have contractors that come in with a limited subset of permissions and they need additional access to something, you could request access to additional features. Like, hey, maybe I need access to this database for this day, and then a short-lived certificate can now be issued for that user, for that database, and then being terminated in real time or when it expires on that. And then we have even the ability for a trust federation. So you can have what we call root and leaf clusters or different namespaces. So as you build your environment and you have, client A can't see client B, or developers can't see production or whatever, you can segregate that within Teleport with its trust federation aspect of it. And then remote access, as we call it, to IoT and edge devices. Wherever those devices live, it doesn't matter which cloud, public, private. I was talking to a lady the other day, they're doing some really cool stuff in Africa, so they're using edge devices, using a lightweight version of Linux out there. Where something like this would work well, our team builds out binaries for ARM devices, for Raspberry Pis, and a variety of different devices out there. So as long as there's internet connectivity, you can put the binary on it, then you can probably leverage Teleport. So from a high level, this is kind of what it looks like and how it works. A user over here, your developer side of the fence, where you need to gain access to a Kubernetes cluster, maybe a MongoDB or Postgres database. And typically in the past, you just SSH into it and you go. Well, now with Teleport, you authenticate into your OIDC, GitHub. GitHub says, hey, you have rights and permissions. So now we're going to issue you a certificate that's signed by the Teleport Certificate Authority. And that certificate is going to say, hey, you have access to Mongo for 8 hours. Have fun. Go enjoy. And then you connect. Teleport's now going to audit that connectivity and that logging across the board. So you still use the same tools you're familiar with, whether it's a browser-based tool, kube control, database client tool like Popsicle or pgadmin or something like that, or even TSH, which is a binary replacement that we have that replaces the SSH binary in your local system. And then you can have actually integration within tools like Slack or Mattermost or PagerDuty or Jira. So you can have that kind of real-time, hey, I need elevated access to something. So you can request that and manages it through the system. All right, so we're going to segue here into a demo, and I'm going to be demoing our open source piece here that runs within Docker and show you how easy, how fast you could actually get going today, and pulling it off our GitHub repo and kind of going along that line. So let me switch context in a few things here. So what I've got here, so I've got a couple, hopefully it'll show up a little bit easier there. I'll zoom in here a little bit. Is, we've got I've already got a pre-container downloaded that I pulled off our repository of Quay. So I've got an Ubuntu container that we're going to run, but I'm going to run Teleport in a container. So what I've done here locally, I've created a file, a directory called teleport-ato. And within this directory, there is a couple folders here that config and data folders that my Docker container is going to need in order to run. So what I'm going to do is I'm going to run initially here, I'm going to run and build out my my container here. Actually, I need to, that's the wrong command there. So that's the thing, when you do something live, you're always going to get something, and that's why you always practice to have to make sure you don't screw something up. Oh, see, let's clear that one out. And so what I'm doing initially, I'm going to run a temporary container here that's going to basically build out a configuration file that I need to build here. So let me do teleport-ato. So we're going to build that out. It's going to run and dump a teleport.yaml file as a configuration file. Then it's going to remove that container, and I should be good. So now within my system here, if I go to my config, I now have a teleport YAML file. And this YAML file is kind of how your system, your server communicates. Lets you know which protocols you have, who the authentication server is, in this case, localhost, what systems I have up, like I have SSH turned on and a proxy service turned on as well. So now I'm going to run this one here, and I'm going to run up a couple extra ports here, and it does not that, so I'm going to do this. Get rid of that one there. Let's try that again. So now I have Teleport up and running here in my Docker container. I'm running it as a kind of forward process in essence. So I've got Teleport running here. So now what I need to do is create a user. So now that I have it running and it's good to go, so I need to actually connect to this container here and create a user. So that way I can continue onward here. So. Do not need the .a because that will not work. So I'm going to exec into this, and I'm running a command called tctl, which is a teleport administrative command that lets me add users. And then here I'm adding a user, and I'm adding them a couple roles, an editor role, an admin role, an access role. Then I'm giving them a couple permissions. I'm giving them the ability to log into a Linux system as either a root, an Ubuntu user, or an EC2 user. So that, in essence, so I'm creating this user, so we're going to do this. So I'm going to run this. Uh-oh. Oh, you know why? Because I had renamed my teleport to teleport ATO. There we go. All right, so over here we got logs file. So teleport sees what is happening, says, hey, a new user has been created. So part of teleport, and this is in the open source here, when you're using its local database, you have to go to its web interface in order to create it. We have multi-factor authentication turned on. So I'm using Safari because it's a self-signed certificate for this. So I'm going to say, yes, let's visit it. And yes, I'm going to visit the website. And Apple wants to make sure I'm legit, so we'll say yes. I approved all of that. So now I'm at the console here. I'm going to log in. I'm going to say, hey, put in my password. And then a two-factor token here. So I'm going to grab my phone. And this is kind of part of, as we look at it from a security perspective, you can disable this if you're running this in your own cluster. Probably don't recommend doing that, but it is the possibility, for someone to do that. So I'm going to go ahead and here create my QR code, not QR code, my one-time password, and then put this in. And I'm going to create my account. So now I'm in. I'm logged in to Teleport as a user, and let's zoom in here a little bit so we can see a little bit better there. There we go. So now I'm in as a dashboard. So now what can I do now that I'm authenticated within the system, within Teleport? Well, I can now access different resources that I have. So with this, since Teleport's running as a Docker container, I can actually SSH into this container. You notice when I created that user, I signed it a couple login names, and now these login names are showing up here as either root, EC2 user, or Ubuntu. So if within Teleport, I can now connect to it. It's going to open up a web-based SSH. So now I am in this container. I can see do whatever I need to do within this limited container. I can run commands, and do work. So if this was a remote node or something along that line, I've got it. So here's what's happening from the teleport piece of the puzzle. There's a couple things. One, we have an audit log. So it says, hey, this user has been created, or this aspect of it, this user has started a session within an environment. When I open up this audit log, I get a nice JSON formatted log file that I can kind of see a little bit more of details of it and what's happening within, that session. And I can see an active session going on. And this is great when you got distributed teams and environments that you could actually see what's happening kind of in real time within your environments. And you could actually join these sessions. So I could actually join a session. So if you're using peer programming, or maybe a production server requires multiple people to authenticate and be a part of it, you could actually join that session. But I'm not doing it since I'm the same user connected here, but just to kind of show what's going on. So let's say I'm done and I log out, I've finished my work. So I'm exiting out of this, so my browser tab goes away or it exits out there. Yes, I'm gonna leave that page. So my active sessions disappear. I now have that session recording, as I mentioned earlier. So I can actually go back and hit play and find out what happened. So you come in on a Monday morning and you see that, hey, we had a production server go down over the weekend, or we had something happen. And you log in and you can say, there's a couple of recorded sessions here. Let's go see what's happening within our environment. And you can actually play that back and use it. We had a customer actually say, hey, we use this for engineering onboarding, like postmortems and things like that. I can pause, I can fast forward, I can kind of zoom back and forth within that. So you have the ability to record what's happening within your environments. Now, from an end user perspective, it's just transparent. I'm just doing my work. I don't have to worry about this. But from an audit compliance, Teleport is capturing all of this and recording all of it, which provides the nice ability to do all of that. So what do you say? Well, let's add a new system here. So I'm going to add a new user, actually a new system here. So we're going to go to the command line. And I can do this from the web browser. I can actually log in from a command line as well to access my resources using, TSH. TSH is our command line tool in order to do that. So I'm going to log into this, TSH login. Logging as insecure because this is a demo environment, so it's going to ask me for my username, password, and it's going to ask me for my OTP as well, so I need to enter that in. Because this is a separate session from my browser session. Our browsers use WebSockets and secure WebSockets for managing that, whoops. Whereas the command line, we're just actually saving those SSH certificates in a temporary teleport directory. Let's try this again. 6, oh, it just changed on me. 9, 3, 7, 4, 9, 1. All right, so I'm success and teleport logged that, so I can actually go back here to my audit log and we can see where it failed because I put in an invalid, but also will let me know, hey, if I'm authenticated in, oh, that still didn't lock me in. I'm struggling today, guys. Let's try this again. There we go. So now I'm authenticated in, and we can see I'm logged in as ATO local host, what access, what roles I have on that. And when I talked about earlier about roles, what users can and cannot do, it's all based here within the teleport roles. So when you download the open source teleport and you fire it up, it's going to have these 4 basic roles that are out there that you can then modify and leverage. All the roles are written in YAML. So if you hate YAML or you love YAML, it doesn't matter. You're going to get it. So everything is written in YAML. You can modify this. So when I authenticate and log in, I have a 30-hour, token or certificate that potentially I can have based on what role I have. And, idea behind this is that you store these roles in GitHub or in your, source of truth so you can kind of manage access to that and limit. 30 hours by default for an admin, probably not the best. But if I'm an auditor, if I have an auditor role, it's going to be a little bit more limited. I can only list and read events and, maybe have a shorter time to live on that. But because I'm in as a few different roles here, it's taken precedence. I have one role that's only 12 hours, so it's giving me a 12-hour certificate. And this is an SSH certificate that I have. So once that certificate expires, my access to these systems is now gone. So I'm going to go ahead and create a token. So now I'm going to add a secondary system into Teleport here. So I'm going to fire up. I'm going to create a token here and give it 10 minutes to live. And this is how easy it is, in essence, to spin up a new environment to join your cluster. It creates a join token that my other VM would need in order to connect, a CA pin that's sent by my certificate authority, and then the authentication server for, in this case, this Docker container and which port it lives off. And it tells me this token's valid for 10 minutes. So I have 10 minutes in order to get my new system up and running. So let's do that. We're going to do a Docker start, an Ubuntu ATO, and then I'm going to attach to this container. So we can see here within Docker, I now have another container that's started. So this is running, Ubuntu on it. I have the Teleport binary downloaded, but I have not installed it yet. So I'm going to extricate it. I'm going to expand it out here, and then I'm going to cd to that directory. And so within that, there's a couple binaries that you'll need to run, and an examples folder there that gives you some details on it. So this aspect, I'm going to run this command on it. So let's, oops. /. So now I'm going to run. Uh-oh, let's try this again. There we go. So now I fired up a node that's running Teleport. And you notice its handshake, we saw some activity going across here, and we say, hey, a node has joined the cluster. So Teleport is listening. That node says, hey, I have a token. I'm supposed to talk to you. Is that token valid? Teleport says, yes, you're valid. Welcome to the cluster. So what happens on the back end is that those clusters, it issues a host CA for that end node, and they send mutual TLS certificates across the wire on the back end, so that way the cluster can trust itself. So now I can go back here to my servers list, and voila, just like that, there's my new server. And so if you've seen, I haven't uploaded any SSH keys to the server yet, but I can connect to it based on whatever user I have rights to. So I can log into the server as root. I'm on this box, run whatever commands I need to do. You can see my Teleport directory. Teleport, on the other hand, is starting to audit this to see that, hey, this user has created a session within that new environment. Here's what they're doing. And we have two forms of logging. This is kind of our default logging, where it's just kind of basic, let you know, a user's connected, they've done this, and it's doing a session recording. We actually have an active session, so I could actually join this session. And then when it expires, when I exit out, we'll have a session recording of this as well. We also have Berkeley packet filtering in it as an option that you can turn on. So if you need to have really kernel level logging and details of what's happening within a cluster, you could actually enable that on some of your systems. So now let's say I do my work and I exit out and then I'm done. So my active session disappears and I can go back here and I can see I've got a session recording that I can now go back and play back. Whether I can play it back in the browser or I can play it in the terminal, however I want to, however I need to, can do that. So just like that, with just from a simple Docker, and this is in our examples, and I'll have a link here in our slides when we go back to it. So you can actually go to our website, our documentation, download our open source, where you can fire up Teleport, play with it, experiment with it, and get it going, literally within minutes along that line. I want to show a couple pieces here from one of my other clusters that lives out there that's on, say, the enterprise side, but our Kubernetes and database access to it. So it's the same idea, the same principle. What it looks like, I'm going to log in on this one as a GitHub user onto this cluster. And that's going to show from here, you can see I've got a couple different environments that live on AWS, that live in GCP. I have a Kubernetes cluster, so I can actually connect to my Kubernetes clusters, and actually we'll do recording of those on those Kubernetes. Then I have databases as well, so I can gate access to database connectivity. So if I go, and I'll show you here in an audit log, and I'll go for the last 7 days here, and for last week, so you can see what's happening within that cluster. So as of last week, there was a Kubernetes request that this user made. And because Teleport's protocol aware, it knows, hey, this is a Kubernetes request, this is a database request, here's what that user was doing within which namespace, what command, what Kubernetes request they were running. And whether it's Kubernetes or whether it's database, Teleport is going to capture all of that information across the wire. And and this because I had a lot of Kubernetes stuff running there. And so I'm able to see that and even do session recordings. So if I look at a custom range here, so I can see where here's actually a session recording of a Kubernetes interaction. So if, a lot of times when you're in Kubernetes, someone execs into a pod, they get out or whatever, you don't really have a lot of insight what's happening that. Well, with Teleport, you can actually record in that session recording what's happening within your cluster and go along that line. So if you scale this out across with databases, being able to gate, being able to manage databases, manage users, manage access, you can see it can get really powerful and really beneficial for environments, for folks to do that. So going back here is like, how do you begin? Like, where do I start as a user? Well, we can contribute on GitHub because we're open source. So GitHub gravitational / teleport is out there. We have a Slack community as well that people are all over the world are part of, and you get actually engineers from our team, or even our CTO participates in that to help answer questions around people leveraging open source Teleport, as well as we got some discussions there. And then of course the docs where I use what I showed here using Docker is actually right here within our documentation for getting started on that. And on top of that, I'd like to shill a little bit. We are hiring. We're a Series B funded company. And we've got, as of yesterday, like 38 openings across the board. We're a fully distributed company across the world. So we got actually someone in Nepal, which is super cool, and people in Alaska, Australia, Europe, all over the place. And we're engineering driven. So out of our 100+ employees, probably 50, 60% are engineers. And our stack everything is written in Go on the back end. Probably some other stuff, but that for sure I know about. And if you want to get a hold of me, have a conversation, I'm downstairs, booth 37 there at the end. But shoot me an email, send a request on LinkedIn as well. I'm also on Twitter, and happy to answer any questions or get some thoughts and hear your if you use Teleport, love to hear. Those are great kind of use case stories and along that line. And I know we got a couple minutes here, so I want to leave it open if anyone had any questions or anything on that, but I appreciate your time.